Hello, I'm here with Hans, Mike and Stewart to talk about polar modulation, an exciting technology that I'm really hoping that this discussion is going to be about these three people and have very little input from me, because I know these three are very passionate about this. We've been talking before we started with the camera, and the conversation, we've had to stop them so that we can actually find some time to record the interview. So I'm really hoping this is going to be some good fun, some interesting insight into what these people think about this new technology, and I'm hoping that you'll find it useful as well. So we've got Hans Summit, G0UPL from QRP Labs. We've got Mike Walker, VA3 Mike Whiskey from Flex Radio, and Stewart Bryant G3YSX, the RSGB Board Chair. So thank you all for joining us.
Thanks for having us.
Thank you.
So the way I want to start this, I think, is, for me, it goes back to Dayton this year. And Stewart and I were there for the RSGB. And Stewart came running back to the RSGB stall and said, there's some amazing new technology going on here that he thinks we should have shared with the RSGB members. So Stewart wrote a little piece for our social media channels, and I posted it over there. And it was all about polar modulation. And we had a photo of somebody on the Flex booth, and we had a photo of somebody on the QRP Labs booth, and Stewart gave me the words for that. So, but that started a great discussion on our social media channels about this new technology. Was it new? Was it based on something else? And that was really the germ of why we're sitting here. But what it prompted is it prompted Stewart to write an article for the RSGB magazine, Radcom. So Stewart, let's start with you and say what grabbed your attention. Why did you write the article?
Well, it's a game-changing technology in my view, and it's yet another example of digital technology removing the limits of analog technology, which is what we've used for many, many years. And I wrote the article to try and explain in simple terms how this worked, so that members of the RSGB, readers of Radcom, would understand how this technology works, which is very much back to the old in very many ways. I mean, it's back to the old days of AM modulation, but done to generate SSB. And it's a really, really interesting and cool technology. And I was so excited. I was so excited when I heard Hans give his talk at 4 Days in May, and then I came along to the Flex booth and saw what they were doing, and it just blew my mind that we were in a new generation of transceiver architecture.
Now, just like you came back to the RSGB stand and said we must do something about this, I know that these two gents, or at least the two companies, were busy discussing things at Dayton as well. So what was going on with your companies about this technology?
I mean, I heard from Stewart first, actually.
Okay.
He came back and he said, you know what, Flex Radio have done this amazing 500 watt transceiver Aurora, which is also polar modulation. You have to go to their booth tomorrow. And that
was a hard secret. We kept that
really
tight.
kept it tight.
And and then Tony, Kilo 1 Kilo Papa, is our developer, and you brought it up a minute ago. He came across this idea organically, and that he had figured out that you could do this envelope elimination and restoration, which is what Leonard Kahn called it. And then he found Leonard's paper from 1952, 58, 52?
52, year I was born.
Yeah, and it's just unique how amateur radio does that, how hams just get there on their own, right? And then I enjoyed watching Tony and Hans having this incredible in-depth conversation for quite a while. I'm sure you shared a bunch of trials and tribulations through the whole event, right? Things that blew up and then it started to work, I assume. I can only imagine. But you got left alone for like almost half an hour. Nobody bothered the two of them. And it was camaraderie.
Because they were just head to head on the technology.
Yeah, it was this amazing camaraderie to watch.
There are probably very few people, I mean, even though Flex developed it into the Aurora, there are probably very few people he can talk to that understand the actual technical parts behind it. And so I think it was really nice for him.
And of course, everybody thinks that two manufacturers are going to be, careful with each other. But actually, the common denominator is the technology, isn't it?
It's 100%.
Just engaging in that and wanting to move it forward. But of course, you've got very different markets, probably, even though you're probably customers of each other and all that sort of thing. But you've got your different
I'm not rich enough to be flexible.
But I probably own everything he makes.
Yeah, absolutely. So do you see that same technology but different markets? Is that the position, or does it matter?
100%. You know, we have amateurs in every snack bracket throughout, right? And
there is an important difference between the two technologies, and that's that Hans uses linear AM modulation, whereas Flex use a PCM-based modulation,
phase and amplitude,
which is fundamentally more efficient. So the question I've got for the QRP world is, when will the QRP world come up with that?
I mean, I think that's not a fundamental difference in the technology, but it is a difference in the way that the amplitude modulation is performed, and much more efficiently. And yes, it's something that I would like to experiment with in future. It's definitely, as soon as I get some R&D time, try out a more efficient way of doing it, as Flex have done in Aurora. Because in order to get that really high 85%,
85 to 90%,
you have to do the pulse, the PWM modulation of
so who's going to explain it for everybody that's watching in small, easy steps? What's the difference?
So it's a combination in the Flex world. It's like DSP for the transmitter. So Flex has been very good in the receiver world, and then finally, we were talking about, we haven't seen a change in the transmitter world in 100 years. Okay, Second World War. So by breaking down the modulated signal into phase and amplitude, and you're going to correct me if I'm wrong here, we then modulate things a whole lot differently. But the key part is we get to amplify it at Class D levels rather than Class A or AB. And that allows us to deliver that 500 watts drawing minimal current and significantly cooler, which is sort of like all these things. If you had told any of us earlier, going, you're nuts, you need to generate 500 watts of heat if you're generating 500 watt or more. And as an example,
I think there's more to it than just the RF amplifier is in Class D. So
correct.
But you also then have to consider the amplitude modulator for the amplitude modulation. And you're doing it the right way because you're doing pulse width modulation of the amplitude modulation, which means that basically the transistors are on or off. And then there's a smoothing circuit that takes the average. Whereas in my case, the transistor is partially on, and that's an inefficient way to run it. And so that's a big advantage.
That's a huge difference. If I can say the number, at 500 watts, at 240 volts, it's 3 amps of current.
And you had a great marketing demo in Dayton with the brick resting on the key. So it was running 500 watts all the time.
All day.
Nice and
cool.
cool.
And a boiling hot radiator, and then you put your hand on the Aurora and it was almost stone cold.
So you've eliminated one of the critical sort of design issues in PA design, which is the linearity of the output device. You've moved that, you clearly, something else is going to limit the performance of these systems. Where is the limit now that you've removed the limit from the PA device linearity?
Probably the frequency, how high you can go, at least today.
Yes, I
That's
agree.
why we only produce 200 watts at 50 megahertz. But that's how fast can you switch these devices, right? That's where the power starts to get limited.
Yes. But I think Steve's asking the limits in performance for
Yes. Well, what sets the new
modulation.
limit in performance? The limit used to be PA linearity, the curve of the output device. You've eliminated that from the problem by going to a fully switched PA.
Right.
Where's the limit now?
I don't know yet.
I think if you do...
It's not heat.
No, it's not heat.
When you do pulse width modulation for the amplitude modulation, you have to do your switching many times higher than the audio frequencies you have to operate at. And so that's one limit. There's also limits of the DSP processing itself. And for me particularly, because I'm doing everything at very low power and very low cost, which is the opposite end to Flex radio. And so the DSP rate that I'm using is running at 12 kilohertz. If I increase that, you can get higher performance. But the cost in terms of CPU cycles raises with the square of the processing speed. So you very quickly start consuming more current, needing 4 times, to get a 2 times increase in processing speed, you need 4 times more CPU power, 4 times more current consumption of the DSP, 4 times
Yes.
powerful processor, and that also means higher cost.
Yes.
You know, everything multiplies like that.
Unfortunately, semiconductors are your friend in this, because we know that you wait a year and the performance has gone up, right? I mean,
Yeah.
Just circling back to something, you said it's the sort of the last time we saw a major change was 100 years ago or so. Or,
In the transmitter, amateur transmitter world.
Okay, so are you likening that to the change from AM to SSB, or what sort of scale are we talking in change?
I'm old enough to remember that just starting. But yeah, I would think so.
That sort of level of change.
I think there's a point. Steve Hicks, our CTO, and I had this conversation about, is it makes sense to make this at a 100-watt radio?
Yep.
Today, no, he said. It's still too expensive.
Right.
At 500 watts, it makes a lot of sense.
Okay.
But 5 years from now, will every HF radio at any power run
Mine
the
is
same?
only 5 watts.
I mean,
Well, I don't have to ask him for the details, but I take him with his.
Given that,
But you do it at 5, correct?
Yeah.
given we got an example at 5, which was probably
Right.
unexpected. 100 watt is an obvious.
I know they've looked at it
Yes.
as of recently. Maybe there's just other things to do, but
Yeah.
it's
And is this something that you think is going to be across all manufacturers and things like that? Are we seeing that sort of step change as well?
you would think so.
Yeah.
It makes sense
Yes.
if amateur radio. I think in the Icon Kenwood Ellercraft world, something else might have to drive it.
Yeah.
External to amateur to get there, at least in their engineering teams, because it all spins off.
This is absolutely classic. Software drives cost out of systems.
Out of the system.
We're just seeing another one of those software inflection points.
I think if manufacturers start to produce 100-watt radios using polar modulation, how are Yaesu, Icon, Kenwood going to continue to just justify linear production?
You mean other manufacturers, but those three?
I mean, if somebody starts producing polar modulation 100-watt transceiver, how will the rest carry on using linear, which is more expensive to produce, bigger?
Will we carry on being able to get linear PA devices, because it's getting more and more niche, because other uses are not going to need it. Most other things are not linear in this sort of way that we are. So isn't one of the drivers potentially absence of good quality linear PA devices, which will force this transition?
I see where you're coming. It's like in the commercial world,
Yes.
nobody's linear anymore.
Exactly.
Mostly.
So we're a sort of an island that's demanding linear devices, and that island will presumably not work, right? I mean,
Maybe we're going to see more. I mean, look, love it or hate it. Look at this, the switch to FT8 for contacts anyway.
Yeah.
Or other digital modes in theory would start to pick up and be less just AM sideband. Who knows? It's going to be interesting to watch.
Let me ask a different question though. The current sort of general architecture is that you have a transceiver up to about 100 watts, and then you have an aftermarket linear, and you're in the aftermarket linear business
a little bit. Yeah.
What's going to happen to that business?
That's very interesting too, and coupled with that too is, and this is the research I was just doing this afternoon. What's happening to our noise floor? 100 watts used to be the norm.
Yeah.
And now you need another 10 dB just to get over it, because the noise floor has gone up unless you're in a nice rural area. Yeah. So
well, that's an area that RSGB is working on independently, because we are concerned about the rising noise floor.
And I think everyone should be.
It's a worldwide problem.
It's a worldwide problem, and
absolutely.
I think we're going to, because we are seeing that shift to digital.
Yeah.
Certainly in VHF, UHF, FM will not go away. Decline.
What are the opportunities for, let's call it, the average radio amateur?
Yes.
So what's the impact going to be on them? They've got nice new kits that they can explore, they can build.
Yes.
They've got equipment that they can buy from you. What about development? Amateurs love new things. Where do you see it going? What do you see the amateur?
One of the problems is that many people build classical radios. That's if they want to build a radio from scratch, they're going to build classical radios. If you have to go polar, that's a whole sort of different hurdle for them to climb. So I don't know how that's going to work out in terms of. I mean, kit production, yes, I understand that, and it was really good fun building the kits. But I don't know what the future for home construction of high quality SSB is going to be.
It's going to be harder, like from scratch,
Yes.
and then there will be people who will be able to do it. But micro SDX is
Micro SDX is a good example.
It's a good leading the edge that way as well. I have a couple of my buddies who's playing with that, and they're into the software. They're trying things. So we're seeing a change from hardware development to software development.
Exactly.
Okay. So we're going to end up with modules or whatever where people design their own software-defined radio. And granted, software, as we're finding that software-defined radios and transmitters have less parts counts. And you can rubber stamp the board and then go figure out how you're going to modulate and demodulate your world. And hopefully that's what the youth picks up.
Which I'm sure. And as you say, a lot more software development. People are aware, people have got experience of it. The amateur radio changes all the time, doesn't it?
So we're going to see a GNU radio module to support Polar Mod.
You're asking the wrong person on that one. Why not?
I mean,
Somebody will do
that's
it.
the sort of thing you would need to get it into the average person's.
I mean, I think the advantages of polar modulation are so significant in terms of cost, efficiency, performance. It should start popping up everywhere. You said a lot about the efficiency improvements available with polar modulation, and even though in QMX we don't use pulse width modulation for the amplitude modulation, we still get a significant benefit by the RF part being in Class D. But to me, it's also the lower cost, because as soon as you have higher efficiency, your heat sinks shrink, your board area shrinks, your enclosure shrinks, everything shrinks. So everything becomes lower cost to produce. And it's also the performance aspect. I get very high performance with the QMX, but it was just developed by me. Whereas it's equivalent to something like an Elecraft K3S, which took 20 highly qualified, highly experienced engineers to get that level of performance. Because they're all fighting these curves of characteristics in the datasheet and trying to make them into straight lines. And it's a square peg into a round hole scenario.
Well said.
It just doesn't fit. But it was the only way to do SSB for all of these years. And now we have this old, you could say new technology, I would say new old technology because it's been done commercially and in other areas for a while, but for amateur radio, new technology. That gives us the opportunity to develop higher performance at lower cost. So it's not just about the efficiency. I felt that you concentrated a lot on efficiency, which is no criticism of the article. It was a very informative, well-explained article.
I was going to ask you, but you've already answered some of it, what the next development is. You've said what people need to consider. But I do want to just ask you, what do you think the next thing to do with polar modulation?
Mike was going to tell us his view on that.
We're running colder. The 500 watt transceiver weighs 18 pounds now instead of 50 for that same solution. I think we're just scratching the surface. I don't know yet. We've got this far. It took 6 years for us to get this far, and Tony and his team to get to that point. Check with us a year from now, because even our software developers, who are amazing people, are now, getting their hands on it as well, and we're up to 90%.
I suppose wider bandwidth is going to be more. As people, for example, listen to a whole band and transmit on a whole, particularly the expedition stations, they're going to want to work more stations in parallel. And so I'm sure that the linearity and stuff helps hugely. But also, you're going to have there is the whole problem of how do I transmit multiple signals across a wider band than we can currently do,
and not break, I'm going to say, the FCC laws of 3 kilohertz. So we can do all that now. Except we just have to be selective that all the signals are within whatever that 3 kilohertz. We're hoping to get to the point where the expeditions can run FT8 20 kilohertz wide.
We
do that today in software, as long as the software vendors come up to that. And our radios will already say, oh, he answered up 18 kilohertz. And we'll get to him.
Now we're going to have to bring this to a close, otherwise we're going to go on all night. Right? we know that. I just one last thing. I just want to check whether you accept the fact that amateur radio is old and boring and there's no new technology. How do you feel about that? Because we hear that a lot.
Me personally? No, it is not. Not by a long shot.
No. Amateurs at the forefront of technology, working with companies like you to develop things that are keeping Stewart writing articles and us really interested.
Otherwise,
in what you're
we'd still
talking
be carrying bag phones around.
about.
I think,
Absolutely.
it was an honour for me to meet Gerald Youngblood in Dayton this year, who is the Flex founder.
Yeah.
And he started it all off about more than 20 years ago in QEX with
Yeah.
his
23, yeah.
software-defined
Yeah,
radio
that's
for the
right.
masses. And I think that was really sort of nice to see amateur radio technology coming.
Yeah.
But the linear amplifier thing has gone on for half a century,
Yes.
3/4 of a century,
Yeah.
and hasn't really changed. And we saw things like pure signal, where people are trying to
Yes.
more
Yeah.
linearize
And-
with dynamic feedback.
And it's
But
going
this
to
is
go.
a
It's going to go on all night.
You
isn't
nailed it, though. Just one more thing to say.
Yeah.
Super heterodyne is a century-old technology, and
Yeah.
we're just getting away from it.
Yeah.
yeah.
Yeah. Yeah, and that's what Stewart was saying about people still building those kits like that.
So, I
Taking
mean, but I
stuff.
wouldn't be me if I didn't wonder what AI is going to do to amateur radio. I think there's a whole new future
Lots
out
of
there.
things.
Yes.
Yeah,
And it's going
Excellent.
to come quicker.
Yes.
yeah. We are going to have to finish it there. Thank you all. It's been fantastic. I knew you were going to have a lot to talk about. So, thank you all. It's been a pleasure.
Thank you.
Thank you. Thank you for asking us.